Good morning and welcome to today's T&D World webinar titled Connecting Every Corner, Enabling the Grid, sponsored by AFL Telecommunications. I'm Nikki Chandler, Editorial Director of T&D World with Endeavor Business Media. To begin, let me explain how you can participate in the presentation today. First off, if you have any technical difficulties during the session, please submit that to the questions window and our technical experts will help you out. We do recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with that webinar player. Additionally, we do welcome your questions during the event today, and we'll answer as many of those questions as possible during the Q&A session that follows the main presentation, but send in those questions at any time. We'll be watching for those, so to do so, simply type your questions into that question window in the side of your screen and hit submit. Also, please be aware that today's session is being recorded and will be available on the T&D World website within the next 24 hours. You'll be notified by email when that archive is available. Before I introduce our speaker today, I did want to call your attention to the event resources area. We have a couple of white papers, an article, and a video there for your further information. Now, I'd like to introduce our speaker for today's discussion. Sean Adam is Vice President of Market Strategy and Innovation at AFL. Sean holds a master's degree in electric engineering from Massachusetts Institute of Technology and has over 25 years of experience in the semiconductor and telecom industry with a focus on system-based solutions and architectures. Sean holds over 15 patents across software and hardware systems and products. Today, Sean is focused on developing and guiding AFL's overall growth strategy in the key markets that we serve. We do welcome Sean. Please go ahead.
Thank you, Nikki. And good morning, everyone. I'm really excited to be here to be able to talk about how we kind of connect every corner and enable the grid of both kind of today and the future. So first, just a little bit on AFL. So we are a leader in both products and services for the digital and the energy infrastructure market. So we've been in the U.S. electric grid for over 40 years. It was actually where we really started and were founded. At that time, the A in AFL stood for Alcoa. We service the energy grid, we service the hyperscale data center market around the globe, and we service telecom and broadband carriers. So we're a global company with 6,000 fantastic employees and a number of manufacturing facilities around the globe. So definitely look forward to talking here today. So the U.S. electric grid stands at an inflection point. I doubt any of us would really question that. And the utilities are actually faced with a vast set of challenges that are requiring the transformation of the grid. There's the aging infrastructure that we're all aware of. 70% of transmission lines are approaching end of life. We have extreme weather events. So as of November of 2024, there's been $24 billion events, and the average 3-year cost is $147 billion per year. Load growth is going up for the very first time in about 15 years. It's generally been flat to down. Now it's being driven by very much by Gen AI data centers. The bringing of manufacturing back to the United States. And a recent report from Grid Strategies shows that we now expect a 74 gigawatt increase in peak winter demand by 2029. So that's an acceleration even over kind of some of the past estimates of where we thought growth was going to be. And then, of course, renewables, which still remain a very strong portion of the generation that's being deployed. We've just recently gone through a U.S. election that will probably have some impact on exactly where some of the spend occurs as we move forward, and the administration sets new policies. But there are a significant number of projects that are already in flight in that renewable space that we would expect to continue. So a key challenge we have is that it actually takes too long to interconnect new generation to where it's needed. Um, and so we are at the end of last year, there were 12,000 projects seeking to interconnect, right? About 1.6 terawatts of generation and about a terawatt of storage. And that was a 27% year over year increase. It relates to 21,000 miles of proposed infrastructure additions. But the key challenge is the fact that the average time from the point of a new service request that you see in the infographic all the way over to commercial operation, right? The average time is 5 years, right? And that's the key challenge, because the energy demand that's being driven, especially as we look at the data center space, they don't think in years, they actually think in months, right? And so how do you actually quicken, right? How do we actually help this demand to be serviced quicker than that 5-year factor? And the other challenge we have is that we're actually literally throwing away power, right? So it's called curtailment. So why do we end up actually, we've got this demand. The demand is too, something we can't support. Yet at the same time, we're actually throwing energy away. Why would that be? Well, at times we actually are generating power through solar, through wind, where there is no demand to take it. Right. That's one of the reasons why, by the way, there's a terawatt of storage that's actually in the interconnect queue. Because storage is a key component to actually help address curtailment. The other thing is the fact of there's times where the grid itself just can't support it. Right. The demand might be there, the energy is being generated, but the grid is at capacity. Right. And so in the end, you actually end up throwing away energy. And if we look at California, right, in 2023, they actually curtailed 2.6 terawatts of power, right? That's enough to power 300,000 homes for a year. If you look at the Southwest Power Pool, they actually curtailed 6.3 terawatts of power, right? That's 600,000 homes. So that's how much energy we're actually throwing away, right? Because it's either being generated at a point where it can't be used or that the grid can't support it. So what's happening to address these challenges? Well, the Department of Energy actually released a very, very good report called their Liftoff report. And they identified really 4 key areas of investment and focus, right, to actually help address these challenges. One is advanced transmission technologies. So those are solutions that really look to increase the physical line capacity. Right. A great example is advanced conductors, right? So these are composite-based conductors. They're able to carry greater capacity. They're able to go longer spans. They're coming from companies like TS Conductor and CTC Conductors. And so that's a key area. Another is grid-enhancing technology. So that's optimizing and really enabling in an adaptive manner to get more out of the grid that's there today. Dynamic line rating is a key one. And FERC actually has recently released in this past year, right, a kind of a public notice of the plan to actually implement DLR requirements. Today, that's not there. Like FERC 881 doesn't require DLR. It does require ambient adjustment, but not full dynamic line rating. But FERC is moving in that direction. The next is situational awareness and system automation. So these are really those control systems, right? Your DERMS, your ADMS, right? Also actually having components in the grid that can be controlled, like smart reclosures. So that's all around the fact of being kind of aware of what's happening in the grid generally through sensing, right? And the ability to actually act on it through a remote manner. And then you actually have a set of foundation tools and systems. And one of the things that the Department of Energy has identified as a key foundational component is the communication infrastructure. And that's really what we're going to talk about here today. Because there's all these advancements that are actually going on as you think about it around kind of the electrical characteristics of the grid that are absolutely necessary. But in parallel, we actually have to have a communication infrastructure that goes hand in hand, because that's the foundation that we're built on. So we have first survey question of 3, right? And so this one is, for you, what is the primary driver? What is the primary driver for your company's grid investments? Is it load growth? Is it the aging infrastructure challenge we've talked about? Is it simply reliability, which is actually the number one thing that a utility actually it must deliver? Is it resiliency, or is it actually some other reason that you're actually driving grid investments? So we got some answers coming in today. Couple folks. Oh, a bunch more. Okay. We'll give a couple more seconds for folks to chime in. What's really interesting is as I'm getting to kind of watch them live, it really is changing as kind of time goes on. All right. Well, let's actually post these up. So, Janine, if you could do that. So 33%, it's addressing load growth, right? Then you actually kind of have the next two being aging infrastructure, reliability being pretty close. Very little bit on resiliency, right? And then kind of a set of others, right? And the kind of the results are still coming in, right? But basically, it's as they've adjusted, we actually have load growth and reliability really kind of coming up to be about kind of 30% each. So great feedback. So as we look at the communication infrastructure that really is foundational grid, this is a great infographic actually that is in that Liftoff report from the Department of Energy. And what you really see, if you kind of start at that upper left-hand corner of the infographic, it's kind of the start of everything, right? It's that large generation, right? Whether that's gas or oil or nuclear, right? It's that large generation that then comes down through the transmission lines, right? And then moves into the distribution space. At the far right, you actually have our consumers, right? Our homes, our businesses. Of course, interestingly enough, there, as we look at renewables, we look at distributed energy resources, you actually have generation also now exists at that side as well. Controlling all of this is the utility control room, right? And the only way to actually be able to effectively manage this is to have the data. And that actually means that as you look across this, there are most of the pieces actually require a strong communication infrastructure. So as you kind of look at those red boxes, you see whether you're actually talking about a smart reclosure, right, or you're talking about a virtual power plant, you cannot do that without a robust, higher bandwidth, lower latency communication infrastructure to support it. And that's a key thing that has to change. And it really is, I'm sure many of us, right, have actually heard the fact of kind of the grid's communication infrastructure through its history has been one way, right? And we all know that has to change, right? But it's more than even just changing to two-way. It really is kind of fundamentally becoming this much more complex kind of like interstate highway system that needs to be there. Because you have all of these distributed resources, whether that's energy generation, whether that's sensors, or that's control. And so to do that, you actually need a high bandwidth, low latency, bidirectional mesh communication. So fiber is actually the only future-proof solution that can be deployed. And the reason we say that is because we've actually yet to find what is the upper bound of the bandwidth that fiber can support, right? The limits actually figuring that out actually tend to be more of the electronic actives than it actually is in the fiber itself. And so as you think about the fact that the investments we make in the electric grid are generational investments, right? These are investments where the communication infrastructure you put in has to last, right? Decades, 30, 40 years. We're not talking 10, 20 years, right? We're not talking like 5 years, which is what you often hear in kind of the data center space, right? We're talking about something that has to be able to work 30 to 40 years from now, just as effectively today. And it's got to be reliable, and it has to be cost effective. And the way we like to think about that is with an acronym called SAFER, that you actually want to deploy a safer network. And what that stands for is one where the infrastructure is sustainable, it's accessible, it's flexible, it's expandable, and it's reliable. By building a network that's founded on these principles, what it means is that what you put in today is going to be there for 40 years. What it also means is what you put in today, you're going to be able to go back and build on it, right? You'll be able to, it's got to be an accessible design, very easy to work with when you deploy, easy to work with when you want to upgrade. It's got to be flexible, so it can adapt to the new needs that are within the grid, and it's got to be expandable. The ability to the fact of, I can put in a certain amount of infrastructure today, and in the future, I can actually tap off it and kind of continue to add new capabilities to my grid. And really at the foundation of communication for the grid has always been built in optics, right? So for over 40 years, optical ground wire has actually stood as this dominant communication path in the US transmission grid. And the thing is, we continue to innovate, right, and drive advancements in that space. Very, very similar to kind of the advancements that you see on the conductor side from those companies like TS Conductor, right? So when we look at kind of traditional OPGW, let's say on that left-hand side, using 250 micron fiber, you could fit 96 fibers, right, with an outer diameter that had about 0.555 inches. Today, through advancements that have been done in the fiber side, you're actually now able to achieve 144 fibers in that exact same space, right? Similarly, if density is not what you need, but what you want to do is drive down to a smaller cable, well, that's possible as well. And you can see that in the 96 fiber example. And on the far right, you see the fact that we are now able to build, right, optical ground wire that supports 432 fibers. And that's with an outer diameter of 0.667, right? And that's been enabled through the advancements, right, and the spend in advancements in the fiber itself, and actually how we create the actual optical ground wire cables. And the thing is, it actually has been part of a solution ecosystem, right? So you need optical connectivity that goes along with this. You need the conductor hardware, the ability to actually mount that OPGW to the towers. And you need the equipment to be able to test it, inspect it, and clean it, right? And so OPGW alone doesn't solve your problem, right? Optical cable alone never solves your problem. It actually has to be a full solution that is actually addressing the problems of the grid. So, next survey question. What communication technology are you most likely to deploy in the next 5 years? Is it private LTE and 5G, and that might be backed by fiber? Is it fiber itself? Is it power line communication? Is it a wireless mesh, kind of like Zigbee, or some other? So if you can start to take that, we'll see how the responses come in. It was interesting, actually. The very first 3 people that answered, each one chose a different one. All right. I think we're kind of getting down to. I think we probably have a good enough results in right now if we want to share those up. And what we have here is about 26% private LTE, About 50%, now it's still adjusting, but a little bit around 50% is actually deploying fiber. And then you actually have kind of a smaller distribution into the other solutions, right? And that very much makes sense as we think about as this kind of the demands on the grid, what's being put into the grid. You actually need those solutions that are higher bandwidth, that are lower latency, and even actually when you're deploying a private LTE or 5G infrastructure, right? Fiber ends up being the key backbone that's there. All right. So technology is great, right? I'm an electrical engineer. I absolutely love technology. But it's only great if it actually solves a problem. And so if we think about the fact of kind of as we think about, the industry thinks about, what needs to be done in the optical space, what are the things we keep in mind, right? And one is we got to reduce the size of any of the optical components that are part of this ecosystem, right? We've got to reduce the deployment complexity, right? And we actually have to look for ways to actually address one of the single biggest challenges that gets listed, whether it's deploying in the electric grid or it's deploying outside plant networks for telecom carriers, right? Which is permitting challenges. So what are the things that we can do, right, to address that? And the industry really has focused on ways to do that, both in the aerial right away and underground. On the aerial side, right, you actually have solutions like ADSS. That allows a utility to deploy the communication infrastructure in the supply zone, right? So in the area that is completely within their control. And of course, solutions that actually can deploy in the comm zone, right? Which is typically where the service providers are going to be deployed. And there, again, you could use ADSS, right? You could use standard loose tube. You could use modern flexible ribbon designs. And we'll be touching on those as we go through the rest of this webinar. But then on the underground side, right, there's also advancements there, right? So you have standard loose tube, right, or micro cable designs that actually allow blown deployment. You have the use of ducts, right? And so again, ADSS, micro cable, loose tube, modern flexible ribbon, all right can be used in duct work that is actually put in that allows you to have that expandability in the future, kind of part of the safer network deployment. And of course, you have direct buried, right? And so in all of these spaces, right, we've had to make advancements in the optical cables to really deliver on those things we've talked about. How do you make them smaller? How do you make them easier to deploy, right? All of which, because that enables, if you could enable a utility to make better use of their existing footprint, right, then their permitting challenges decrease, their costs decrease. And that is a key focus, right, of those that are trying to serve the utilities in this foundational communication space. And if we really think about kind of what is kind of a fiber to the meter architecture, what's very equivalent to a fiber to the home broadband solution that a service provider would do. But there's actually this corollary that is between the optical comm infrastructure and the electric power infrastructure, right? Your generation on the electrical side is really equivalent to your internet service provider. Your substation on the electrical side is really equivalent to that central office, right? And so as you move kind of down and follow the fiber, follow the power all the way to the subscriber, there really is this one-to-one corollary between the electrical infrastructure and the communication infrastructure, the fiber infrastructure that goes along with it. That actually also means that, again, the fiber infrastructure, that the advancements we do have to be able to keep up with that electric grid side, right? Because they really are actually happening in tandem. So ADSS, as I mentioned earlier, this unlocks the supply zone. And why is that interesting? Well, one, it actually gives greater pole flexibility, easier permitting, and it actually reduces your make-ready costs. That's a key benefit. Overall, we estimate that the total cost of ownership in an ADSS system over your typical strand and lash that's happening down in the comm zone is at least 20%. You don't need any messenger wires. right? And I don't know about you, but certainly as I walk down the street and I look up at the messenger wires, a lot of them fray, a lot of them fall apart. It's actually one of the key ongoing maintenances that actually has to happen. You don't have that with ADSS. They're actually designed to meet the challenges of ice and wind, right? And you actually have that overall reduced kind of maintenance cost reduction. And again, with this, you need an ecosystem of solutions. So you actually need that conductor hardware such that it can be effectively mounted to the poles, right? You need the optical connectivity to be able to go along with it, right? Whether that is splice enclosures or terminals, right, or connectors, all of that is necessary at the level of kind of requirements of a utility reliability to be able to support the solution. Next is microcable. And really, actually, this is a step function in efficiency. So for microcable, right, you can kind of think about it as just like your traditional loose tube that you're very used to working with if you're working with fiber optics, but significantly greater density. And you can actually see that from these pictures, right? Look at that. In the far left, what you have is that traditional 144 fiber loose tube. Right next to it, same density, 144 fiber, but this is outside plant heavy duty microcable. Look at the OD difference. And then think about how kind of moving down to a cable that's smaller, that's lighter, right, allows you to actually make more effective use of your assets, whether those are underground or they're aerial. And as you see on the left-hand side, as we talked about microducts before, right, deploying a microduct, especially one as you see there on the far right, where you actually have seven available ducts. You put that into the ground. Most of the cost was in the digging, not in that duct work. You don't actually need to use all 7 of those day one. This is one of those places where make the right investment in your infrastructure, right? Use, let's say, 1 or 2, just the number of ducts that you need to be able to support the communication infrastructure you need today. But then you actually have these additional ducts that you could actually blow fiber down in the future, right? And achieve kind of a 7x increase, from your day one. If you only use 1 duct day one with 144 fiber, you actually have the ability to get 7 times that through the future of your network, right? No digging, it's already there. So that's key. And then what is actually really a transformational level of communication capacity comes from what is often referred to as modern flexible ribbon. And this is really a significant breakthrough that allows for an unbelievable amount of fiber density, right, within the same or smaller footprint that you take today. And what I'll tell you is certainly a place where this plays is in that Gen AI data center space, right? Actually, the very backbone of the ongoing investments in AI, but by all the large hyperscalers, sits upon modern flexible ribbon because it's the only way to achieve the level of density that they need, right? And so there, what you see in that top, right, is a comparison of a 432 fiber between standard loose tube at that 21 millimeter OD coming down to, for the flexible ribbon solution, 13.5. But what's really more exciting is look right below it, right? That's 3,456 fibers in a single cable with a 30 millimeter OD, right? So modern flexible ribbon, these advancements in fiber technology are really actually allowing for greater levels of capacity, right? While at the same time actually reducing the size of the optical cable. So, but as I mentioned earlier, we kind of talked about the ecosystem. Cable alone isn't a solution. It's just cable. What you also need is made for purpose optical connectivity. You need optical enclosures. You need terminals that are designed to make use of these greater levels of density, delivering the same thing, that same ease of deployment we've talked about for the cable, right? Focused on really how do you let the utilities make better use of their existing vaults, whether those underground vaults, poles, their right of ways. So size is key, right? So all of that needs to come down, right? And what optical connectivity really does is it protects really those critical network connections in fiber. And when you're actually deploying underground, you actually have to think about the fact of these solutions have to be sealed to prevent water ingress, right? So they are tested to the most stringent standards, right? And that's one of the key things is when you look at the optical connectivity you buy, don't go cheap. This is not the place to actually kind of not focus on getting something that you know has been tested truly to the standards that are necessary and can stand up to, right, the harsh environment that is out there, right? As we saw in the poll earlier, what was kind of one of the top reasons for investments in the grid? Reliability. And so it is absolutely key that when you look at your connectivity solutions, you know that they're going to let you deploy a reliable network that will last generations. And you also want to think about the fact that they're delivering on that flexibility, that accessibility. So modular, easy to deploy, so toolless, ones that don't actually require you to be carrying around a lot of tools. The ability to re-enter these enclosures without actually disturbing the connections that are already there. Those are the type of things you want to think about in your choices for connectivity. As I said, it really enables this safer network, right? Sustainable, accessible, flexible, expandable, reliable network in a way that maximizes the existing infrastructure, reduces that deployment time, eases permitting challenges, and delivers the reliability that is the absolute #1 requirement for a utility. And so innovation here continues, right? It's very much focused on addressing those key areas, right? Going hand in hand in those advancements in the optical cable and optical fiber side. Other ways, and it's kind of really you think about it, the investment, you think about it, the innovation needs to actually happen on all fronts for this to work. And so one of the other areas where advances have occurred, right, really focusing on, how do I actually reduce the amount of labor that I need? How do I actually achieve a smaller footprint in an underground deployment? Again, allowing utility to make better use of their existing right of way, right? And actually, how do I reduce transport costs, right? How do I actually have to have less trucks driving stuff around? Well, one of those is actually advancements in the handholds themselves and development of things like collapsible handholds, right? Where, concrete requires a lot of heavy equipment to lift it, but plastic and composites don't. It's kind of similar to the advancements that you see in those advanced conductors where a composite core, right, allows you to actually have this greater level of capacity and this greater level of span on that conductor. Kind of innovating here, same thing, move away from cement, move away from your standard kind of, let's say a metal infrastructure, right? Make use of the advancements that are there in composites and plastics, right? To be able to unlock something where it is actually a collapsible handhold. And as you can see from the picture, you could actually just put these on the back of a pickup truck, right? So think about the fact that you could fit 200 on a flatbed versus, let's say, 50 to 80 concrete handholds, or you could actually just throw 5 of them into your standard pickup. And you actually only need 2 people to deploy. You don't need any equipment. Those are the types of things that the industry is focused on delivering to utilities, right? Such that they can make better use of their workforce, better use of their dollars, right? And actually better use of their existing right-of-ways. So now to our last survey question, right? Are you planning to deploy fiber beyond the substation into the distribution grid to support grid automation, right? Maybe no. Might be yes, but only in very special circumstances. It might be yes, but only in support of a wireless or LTE network. Or it actually might be yes, fiber all the way to the meter itself. So let's give some time for the survey answers to come in. All right. We got a bunch of answers that have come in. Still coming in. We'll give another couple of seconds for folks to chime in. All right. Okay. So let's we can share these up. I think some answers are still coming in, but I think we can share them up. What we've got is, interesting enough, about 45, 46%, now popping up to 47%, say yes, but only in very special circumstances. Then pretty much the other ones, whether it's no, we're not going to deploy fiber to the distribution grid at all, right? Or yes, in support of private LTE, or yes, fiber to the meter, all of those actually are about equal. So kind of an interesting distribution. And what I would say is, this question, as you ask it over time, changes. You know, the answers change. And what truly is clear is that as time has gone on, what you see is this greater level of penetration of fiber into the distribution grid, right? And so, and that's not surprising. That comes from the fact that, you know, that again, that two-way street, right? And it's the fact of, as that street kind of gets further and further, further into the distribution grid, you actually need that strong communication infrastructure in support of it. Awesome. So appreciate the input on that. All right. So, you know, as we think about fiber and kind of the promise it brings, not only does it actually support a smarter grid, but it actually supports a stronger community. Right? So on that fiber backbone, you're actually able to support things like high-speed broadband. I had a phenomenal conversation with a CEO of an electric co-op that's out west. And one of the key things that he thought about in deploying a fiber network, actually a hybrid network, a fiber wireless network, is how to better support the farmers in his community, right, through smart agriculture. We know that the fiber infrastructure is key to that first responder network, and the utility grid can be part of that. And then closing the digital divide in our rural space depends actually on a strong middle mile broadband. And if you actually look at the last year, I think it was last year, it might have been 2 years ago, deployment of $1 billion by the federal government addressing middle mile as part of the infrastructure bill. Some of the key winners of that money were electric utilities, right? That are leveraging their existing assets, their existing right-of-ways to actually help address the middle mile broadband challenge, right? And that's another key thing that the utilities have, right? When we think about permitting being this huge challenge, at a federal level, a state level, at a municipality level, right? Permitting is the number one thing that delays projects and the studies that go along with them. That ability to use that right away, that already is there for the utility, really makes it this phenomenal highway to address not only the challenges of the grid, but also to enable the other things that are really necessary for us to be the most advanced nation in the world, right? And so it's absolutely key, and communication is all part of that. So I appreciate the time today. You know, I hope you understand that certainly our focus, right, is how do we enable a smarter grid, and certainly AFL is here to help. You know, whether that's addressing the optical cable side, that optical connectivity side, whether it's the handhold innovations, right? The actual conductor hardware, substation hardware that's necessary, all the way to the fact of the equipment necessary to deploy these. And so we're here to help, and I appreciate the time.
Thank you so much, Sean. That was a very informative presentation. Appreciate a lot of that data at the beginning. I'm actually going to be looking into some more of that when I get off. We do have some questions that have come in. I just want to remind the audience that you can go ahead and submit questions now till we're finished, and we will get to those as we can. I do have some in here, so I'll go ahead and start with this one, Sean, for you. What advantage would fiber optic communications have over GSM connection, for example, to the energy meter?
Sure. So great question. As we touched on, what you have with a fiber optic, what you have with fiber optics is really that future proof. And so it's actually a connection that you're going to be able to put in and not actually have to go back and touch. I will say actually, one of the ways that I view it, even though I work for a company that does the optical side, I've always viewed the fact that there always used to be this competition between fiber and wireless, right? This big competition. I don't see it that way. I actually see they go hand in hand, right? And so, I think in situations where, especially as we think about kind of the continued advancement of really how much power is generated and how much power is stored and used, is so much happening more behind the meter, right? That's going to increase. And then the fact of the ability to then leverage the power and the storage that's behind the meter to become part of a virtual power plant, to actually become the generation in the local area. Think about the communication that's necessary there, right? We're not talking about something of reading a meter once a day or even reading a meter once every 4 hours. We're down to the fact of, as we drive through this, you're going to want to be able to read that meter, right, in a much faster basis. That requires greater levels of bandwidth, improved latency. And then if you put all of those meters in doing that, right, this entire community is part of the VPP, you start to stress, right, that radio technology. You don't stress the fiber technology. So now, again, there still are places where what you really want is a hybrid solution, fiber backed, right? But let's say a private cellular solution at the end, especially in places where it's not cost effective to drive fiber all the way to it, or you just have kind of so many significant nodes that driving fiber to each one just doesn't make sense. So hopefully that answers that question.
Yeah, I think so. It really does make sense. And that really did answer my next question, which was, how do you see that trade-off between fiber and wireless and electric grid? And, and I just attended the Utility Broadband Alliance show a few weeks ago. I think you guys were there. And, that the big emphasis was definitely on the private LTE. So it sounds like this works hand in hand, that Absolutely. You almost really have to have that background as far as the fiber goes. Here's a next question here is, how do you see the results of the recent U.S. election affecting the direction of the grid?
Sure. It's the, it's definitely going to have an impact. It's, and I think there's going to be kind of winners and losers on the grid side and the energy side that, from let's say where the last administration and Congress were. But overall, I'm actually really, really optimistic. Right? I think that there's certainly a policy statement of this kind of transition to an energy policy that's fundamentally focused on energy dominance at a global level. Right? It really says there's a really strong focus of how do we actually, there's a view that the grid and is a key component of our infrastructure that must be supported. Energy is a key thing that's necessary. If we can get the cost down here, it will actually help unlock the rest of our potential. And there's always a direct correlation between energy, the access to energy, and really the success, the GDP of a country. So it's absolutely critical. And then certainly kind of the ability to become that dominant energy provider on a world stage is key. I think the focus on reducing regulation and kind of reducing regulation and permit reform that Congress is actively talking about, those are really going to help unlock deployments. And so really, really feel optimistic. Some concerns, I think the tariffs that are going to go in, again, they actually kind of cut both ways. I think they'll actually help address kind of keeping that quality level up as you think about the fact of, not only do things often come in from outside our country that are less expensive, right? But sometimes they also don't have the exact same quality that's coming from U.S. manufacturers, right? And so, and when you look at the grid, you really don't want to be putting that into the grid. So the tariffs help in that way. They help defend U.S. manufacturing and U.S. jobs and U.S. quality. At the same time, it is going to drive costs up, right? Because no matter what, we're all probably getting pieces from outside the United States that becomes part of what we make, right? So you kind of have to understand where that plays out. But overall, I'm optimistic. I think if we can get it, if also inflation can come down, interest rates can come down, you actually might see housing starts improve. If housing starts improve, investments in the distribution grid will go back up. So I'm fingers crossed. So
yeah, and that's a good point. I hadn't even thought about the housing and the distribution grid part of it because I've been thinking big picture with this. But yeah, okay, great perspective there. Okay, so here's the next question. Can you say a little bit more about FERC 2222 and how communications plays a role through that?
Absolutely. So for the audience, in case if everyone isn't clear, kind of what FERC 2222 does is it's really all about kind of unlocking the distributed energy resources that occur in the community, right? And it's really around the fact of how to allowing those distributed energy resources to become part of the wholesale electricity market. And so you start to have it where your dependence is not just on those large generation solutions that are utility scale, but it actually allows for let's say communities, whether those are businesses or those homes, to not only have their own distributed resources, solar panels in our home, Teslas in our garage, and whatever, right? But those actually become part of a localized generation. Right. And what you have is this emergence of kind of the ability to aggregate that power into a virtual power plant. So that's kind of what FERC 2222 enables. But think about the amount of communication you need to have to support that. You actually need insight into what is the generation behind the meter that's within a home or a business. What is their storage, max capacity, current level it is. Right, such that you don't want to wake up in the morning and find out that your Tesla is empty because all the power was used to feed your neighbor's streaming service. Right, you don't want that. So there's all this need to have much faster, higher bandwidth. That's super high bandwidth, but higher bandwidth communication. Right, so that's where the smart meter is absolutely critical. All right. The other thing you actually have to have is so DERs, they're going to actually, so 2222 helps kind of drive the deployment of DERs because now it becomes much more interesting financially for everyone. But there's a downside to these distributed energy resources. They're actually fundamentally a destabilizer to our electric grid. The utilities actually have a nightmare, right? Because they actually need to have a stable grid, right? And this actually can lead to destabilizing it, right? Whether those are voltage fluctuations, frequency challenges. And so that also requires the fact of kind of a greater level of real-time sensing, right? And really kind of time-aligned sensing, right? And so you kind of start to think about things like synchrophasers, right? And synchronous measurements. Again, that all comes back to a communication infrastructure that is not only robust, but actually is high bandwidth and low latency. Otherwise, you cannot achieve this. That's how I see those got to go together.
Yeah. Okay. Thanks for that.
Sure.
Okay, couple more questions before we wrap up here. So one of the promises of advanced conductor solutions, such as those from TS Conductor, is that ability to deal with longer spans. Are there any advancements on the optical cable side that kind of parallel that?
Sure, absolutely. So, as we touched on a bit in the presentation itself, right? We're kind of achieving this greater levels of density through whether it's 200 micron fiber or it's ribbonizing a fiber, and that's a like a kind of a perfect corollary that goes along with the these advanced conductors where they can achieve greater power carrying capacity, but they also go longer spans. So we've also made advancements there. So if you kind of think about a typical span that you're actually having a conductor go across, or let's say ADSS fiber go across, it's usually about 500 feet or so. We actually have, and the industry has kind of created long span ADSS where we can actually span over 2,000 feet, right? And so that allows you the ability to go across longer spans. Is a couple things. One, sometimes you have places where poles have to be far apart, maybe a river, all right? The other times, the fact of one of the things that kind of this ability to reconductor is what they kind of call it on the electric side, right? Is the ability of, hey, maybe actually I don't want to replace the pole in the middle, right? I'm just going to use the two furthest apart poles because I know the span. I know I can achieve that span. It means I actually don't have to replace the pole in the middle. Right? I can get rid of it. ADSS can span the same distance now because we've done a bunch on how do we actually kind of achieve the strength structure of the ADSS, which has no metallic parts in it, by the way. That's why it can be in the supply zone. There's no metal in ADSS cable. So there's not any metal core, metal stiffener, right? That's not there. So think about the fact of how to achieve long span when you actually aren't just wrapped around like a messenger wire, right? That's not how ADSS works. And so we've done a lot of work on actually how you're able to do that through the other components that you actually put into the optical cable. So.
Yeah, it's interesting. As you know, I got to visit your facility last year, and got to see some of that in reality. So that's really neat. One more question before we do wrap up. Can you speak more about what benefit ADSS provides over that traditional strand and lash? And you may have gotten into that a little bit, but maybe clarify that some more.
Sure. So certainly one, as we just mentioned, there's no metallic components, right? So you don't have any, so you can install it up there. The one I mentioned earlier is those make-ready costs, right? If you think about when you're deploying a communication infrastructure, right, along an aerial one, if you're down in what's called the communication zone, you have to worry about things like what's the distance between the lowest cable and the ground, right? Otherwise, you've got a truck might drive through it, right? So you've got this clearance one where it says, look, if I'm going to add that in, I actually have to replace my poles. I have to make my poles higher. The other thing is you're competing for space because on your pole is probably more than one service provider. I can tell you coming down my street, right? There's Verizon, there's Comcast, right? And so those are on those poles, and they're already competing for the space that's in that comm zone. So that make ready one is the fact that because it's done up in the power layer, they don't have to worry about that. They're using the space that's already there, right? There's no metal components, so you can actually just deploy it near the wires, right? And so that's a key thing. Overall, there's lower hardware costs. It's easier to deploy. It actually has a longer expected design life. One, as I kind of mentioned earlier, those messenger wires fray, right? I know. I've walked down the street. You just kind of see where the messenger wire has kind of looks like my hair in the morning, right? It's all over the place, right? You're like, that's actually carrying a piece of fiber. And really, actually, that design for kind of wind and ice is absolutely key. As you think about the fact of ice buildup on a cable, ADSS itself was really designed to kind of shed that a lot easier. And so So a bunch of advancements, and I think actually one of the resources that the audience has access to is actually kind of directly tries to address this question of kind of what are those benefits of ADSS. So.
Oh, okay, great. Thank you. Well, that we'll just wrap up with that then, as far as to remind everyone to look at that resources area and download some of those. We do, we really are getting finished up here, and for any questions that we might not have had a chance to answer, we can get back to via email. I do appreciate Sean joining us today. I always learn so much when I listen to you, Sean, so thanks so much for that presentation and the discussion afterward. And I do want to thank AFL Telecommunications for sponsoring the webinar today. And of course, thank you all for joining. Have a great rest of your day. Thanks.